Okay, so I don't think we're going to go through this sample problem together. I can do a tutorial on it if you want, and then you can watch it at your leisure. What I'm going to say is that on the non-perpendicular vectors, I'm not seeing any of you who I think like, oh my gosh, this person's in trouble. Like, I'm not seeing anybody drowning. I see a few folks where I think like, I have some input, I have some advice, I have things that will help you as you go. One of the big things, one of the feedbacks I always get on this particular chunk of problems every year is they're really complicated, they're really tedious, it's like all this nitpicky bookkeeping stuff, and then we go on to projectile motion and we seem like we're done with this, but we're not. And the hard part about this is we kind of keep building part of a rung and then going to the next part and then putting those two together, and each half of the rung takes a while. So all the motion stuff you did in Chapter 2 builds to the projectile motion that we're going to do soon, and this builds to that also, but it's a little bit complicated. I don't think, based on the results of your FIP quiz and just conversations and observations, I don't think you need a bunch of extra problems to practice the A and B stuff, the solving and resolving vectors. I think you guys are pretty good with that. So I have no desire to heap homework on you for homework's sake. These, how are you feeling? We're going to do a FIP on Monday and then whiteboard it. Here are the pieces of advice that I can offer. Here are my words of wisdom. This is a problem that I totally made up. And this is what, west of north. So I've got some object, some person, some whatever, traveling 6.2 kilometers at 22 north of east, turning and traveling 2.5 kilometers at 11 degrees west of north. Notice that my vectors are not to scale, and they don't have to be because we're not doing a graphical solve, but they should be reasonable, because what can happen, especially when you're dealing with really small angles, is if they're not at least somewhat reasonable, whoops, you get these crazy resultants that totally look different, and your headings can look different, especially if it's a small angle around the axis. You know, you can be saying, well, it's 6 degrees, and it's really west of north, but in fact, your calculations, it should be east of north. So, you know, reasonably to scale. With these, and you don't have to color code if you want to, you can, but I really strongly advise, here's my resultant, starting out every time by doing this. Delta x total squared plus delta y total squared. In some cases, this is not a delta x. In some cases, this is a v sub x. Whoops. There we get into double v sub x sub t, vx total squared, plus v sub y sub t squared. Okay? But whatever the case may be, I strongly encourage you to start there. Because what that reminds you is, oh, hey, the overall thing that I'm looking for is my overall x and y displacement. And it's a good sort of visual cue that that's where this is going. And then what I tend to do is also write down this. And I'll just stick with the deltas because it's easy. Delta x total equals delta x1 plus delta x2. You've got one in there right now that has a delta x3. I'm going to tell you that on your test for this chapter, I give points for each of these lines. I give you a point for this, I give you a point for this, and then when you actually sort of do the bookkeeping, you know, so for displacement 1, well, I know that delta x1 equals 6.2 km times, whoops, would that be, I shrunk my own screen, times sine of 22. Yes. Oh, excellent question. And a good point. Yeah, I generally do. That's one thing where I'll be a little bit more flexible, because it's useful to say, well, delta x1 is equal to displacement 1 times the sine of theta 1. Okay, well, delta 1, or displacement 1 is 6.2 kilometers. Theta 1 is sine of 22 degrees. Okay, I've got that, that's delta x1. If you skip straight to this step, that's not the end of the world. It's not as, I literally do every level of detail when I'm solving these myself. And what it has done for me, and I would swear that my brain is a different creature since I started teaching physics, doing this actually builds structure in your brain. You understand that your brains are highly malleable, correct? And that every experience you have actually literally physically changes your brain. Physically changes your brain. Psychic brain surgery. You're doing it on yourself, you're doing it on your friends, your family, your teachers, everything around you is doing psychic brain surgery on you. Collect good experiences. Building that discipline of stepwise stuff creates a structure in the brain that's helpful in a lot of areas of life. There are things that I'm better at that are not physics since I started doing physics. Weird. So yeah, I tend to do that, but that's one area where I'll give you a little bit of slack. I know some of you are coming from writing down nothing to trying to achieve a level of detail in accounting. That's where I'll cut you a little bit of slack. So then we'll have our final answer for delta x1. You've got one in there where there are 3 legs of travel. There's a D1, D2, D3, and for D1 and D3, in each case, the travel on one axis is 0. Fine, just write that. I literally write delta x on the first leg of travel. What is that, number 3? Delta x1 equals 0. Delta y1 equals whatever it is, 3 meters. Because again, you're doing that documentation and accounting piece. So that's one of the things I really highly recommend. These problems, a lot of them will actually take you they should take you a full sheet of paper. I can show you my physics notebooks from many, many years where I've worked out every problem I assign, and when we have these kind of problems, I typically allow myself a full sheet of paper, and I sort of segment it off and set things aside. It's a little different with using the whiteboard presenter. I do a lot of this shrinking and moving stuff, but anyway, that's just my helpful tips. I will give you the 3C worksheet, which is the non-perpendicular vectors problem. I'm only going to give you a couple from them, but I'll give you all the answers. What that'll do for you is if you feel like you are struggling with this, you can do the extras. If you're not struggling, you do the minimum that's assigned, but it gives you an easy pool of extra problems for practice if you feel like you need it. Questions, comments, concerns? Cool. Then you've got time to work. On Monday, we will have a FIP quiz on the non-perpendicular vectors. Then we'll whiteboard, and I'll post the key.